Hello everyone and welcome to the course of CCNA. You can find this full course at telcomaglobal.com. In this course, we are going to discuss about all the concepts that are going in this CCNA and which will help you to clear the CCNA examination. So let's start with the network fundamentals of CCNA. So we are into chapter 1, which is Introduction to TCP IP Networking. So we know that the networks work or any system work correctly when it has some rules or the various devices or the software follow some rules. Where are these rules come from? These rules basically come from all the standards and protocols where are the agreements of a particular that how the network is going to work. For that we have networking models. These networking models define a structure and different categories of protocols and standards. As new standards and protocols emerge over time, networkers can think of how this working model will work. The companies, those who make the networking products and those who use these products to build their own computer network, they have to follow a particular model. The model that the system is using has some defined rules and each part of the network should work as per the rules so that the entire system can work together. Today, TCP IP rules are the most pervasive networking model in use. TCP IP on every computer operating system from mobile phones to the mainframe computers. Every network built with Cisco products today supports TCP IP. So this model defines a large number of protocols that allows computers to communicate. So this model looks like this. So it has 5 layers: physical, data link, network, transport and application. So the networking model, which is also known as networking architecture or networking blueprint, it is a complete set of all the documents. This is the networking model of TCP IP. TCP as Transmission Control Protocol. IP as Internet Protocol. So this model, it creates a set of rules that allow us to take the computer, plug into the right cables, turn it on, connect and use the network. So layers of this. The bottom layer, physical, it focuses on how to transmit bits over each individual link. The data link layer, focusing on sending data over one type of physical link. Network layer basically focusing on delivering data over the entire path. Transport and application focuses on applications that need to send and receive packet. Again, it is a bottom to top approach, like similar to OSI reference model. Let's start with TCP IP application layer. This layer protocols provide services to the application software which we are using. It does not define the application itself, but it defines all the services that the application need to run. Suppose you have application protocol HTTP. It defines how the web browser can pull the entire content from the web page or from a server. So HTTP overview. To make the request for the web page, suppose we open any browser and we have to request for a web page. So the return of the content of the web page, the application use hypertext transfer protocols. HTTP functionality is there to ask for the content of the web pages by giving the web browser so that it has the ability to request files from the server and giving the server a way so that it can return the content of those files. Suppose we are having a web server and a web browser, HTTP header, okay, and then data transmission is there. We have TCP IP transport layer. Here transmission control protocol and user datagram protocols are the main protocols. They provide services to the application layer that reside on one higher layer. Here it has error recovery. TCP has error recovery service which is provided to application layer protocols. TCP IP needs a mechanism to guarantee delivery of data across a network. TCP uses the concept of acknowledgements. TCP header shows a sequence number for each message. This message, TCP message, is called as segment. Sequence number is represented as SEQ. We have same layer and adjacent layer interactions. In this same layer, interaction on different computers. The two computers use a protocol to communicate on the same layer on another computer. One layer on one computer communicates with the same layer on another computer. Two computer uses header to hold the information that they want to communicate. For adjacent layer, it refers to concept of how adjacent layers in the networking model on the same computer works together. Lower layer provides services to the layer above it. Then we have TCP IP network layer. Network layer includes internet protocol. The function of this is addressing and routing. It defines each host computer should have a different IP address. It defines the process of routing. Routers are basically networking devices that connects the part of the TCP IP network together so that for the purpose of routing IP packets to the correct destination. Internet protocol routing basis. IP header contains a secure IP protocol and a destination IP protocol. So when any router receives a IP packet, it makes a decision. So router will look at the destination address, compare it with the IP router and forward it the packet. This process of forwarding IP packets is known as IP routing. Similarly, we have IP addressing also. Here each device that uses TCP IP, it needs the unique address so that it is identified by the network. This IP address has 4 numbers. They are separated by the periods 1.1.1.1 which is dotted decimal notation. Routers, which are the networking devices, it connects the TCP IP network together for the purpose of routing, forwarding of IP packets. So addressing and routing is the main on this. TCP IP data link and physical layers. These two layers work closely. In fact, some standards which define the data link and physical layer functions as well. TCP IP model. The physical layer defines the cabling and energy. The data link and the physical layer includes a large number of protocols and the standards. It has various functions which are related to physical transmission of data and protocols that use the physical media. Thank you.